All right. Um, okay. Welcome to the first episode of the practical introduction to analytics. This is a live stream series that I'm gonna do. It will take roughly 30 minutes to around 45 minutes per session, and I think this would last probably around 4 sessions, where I'll be covering um, uh, the practical introduction to analytics based on what I've experienced so far as a data analyst and scientist in the last 6 years. And to set the right expectation, this is not a zero to job ready kind of course. As I mentioned, this is a practical introduction. So we will be covering things like definitions, the future of analytics, and probably by the end of the series, I will do a live demo of how you can set up your local machine so that you can practice what normally a data analyst do on a daily basis. So we will set up uh, things like data warehouses, DBT core, uh, and a BI tool. And if those terms are very unfamiliar to you, don't worry, we will be covering all of those in the next um, sessions. Okay. So just to introduce myself, I am Cedric, and if you're coming from TikTok, you probably already know me. But if not, uh, I am a senior data analyst for a tech startup. It's a unicorn tech startup, and I have been in the data space for um, in total 9 years. But I spent the last 6 years dealing with or using the modern data stack. The first 3 years, you can still say it's a data. I'm already in the data space, but I was a reporting administrator. So back then I was just using Excel, and I had no exposure to what they call the modern data stack. So I had no um, experience in my first job with data warehouses or any database of some sort, nor experience with transformations, SQL, and BI tools, just Excel, and doing automations using macro. Okay, so let's move on. Let's start with what is analytics. So let's go first with definitions. And this is how I would define what analytics is. It's using data to answer business questions and make better decisions. It may sound simple, but mind you, this is an entire multi-million industry. Decision industry is a big industry for obvious reasons, right? You can't steer a business into success if you are making terrible decisions. And as companies scale, the more pressure they have to make the right decisions. And when I say right decisions, it should be data driven as opposed to uh, gut feeling based decisions. That would be very very terrible for a business to keep doing that. Um, Making decisions out of what they just feel, right? So to give you a concrete example of what really is answering business questions and what is decision making. But first, let's go with a personal example because I'm pretty sure many of you, in one way or another, have performed the tasks of an analytics team. Uh, so I'm going to give you an example here, sort of like a case study. Let's use a personal example. For instance, you have the question, where did my money go? All right. So the scenario is that by the end of every month, you are expecting to have around like 5% or maybe 10% of your monthly salary uh, remaining by the end of the month. But what happened in the last few months, as you observed, is that you are left with nothing. Like you're barely break even um, in each month, and now you're asking, where did my money go? So again, this is just an example on a personal level. So a curious person who wants to answer this question um, will do something like this. So they'll start um, looking for data, like how can I track where my money goes? So probably they'll get or they will download or collect their credit card statements, right? And probably utility bills too, which could also be already in the credit card statements. But yeah, let's just limit to just two data sources. This should be enough for a person to track where their money goes, right? Um, and then let's see. What you would normally do once you have this data is you want to have a unified view of all this data. Uh, let's say you have three credit cards, right? So each of the statement of three different cards will look differently, right? One will have more information while the other could have less. So you need a unified view so that it's easier for you to do your analysis. So what happens next is to put all data probably manually, right? Obviously, uh, to let's say a spreadsheet like Google Sheet, right? So now you have a unified view, credit card statements in a single table, and utility bill also part of a single table, so that it's easier for you um, to see um, your expenses. So now the next thing you'll do is you will categorize, right? You'll categorize your expenses, probably food or eating out. What else? Utilities. I guess you can just group them together into like bills, depending on how granular you want your analysis to be. But yeah, that's probably what you would do next, right? So you categorize and group amounts. So this is where you will see. Um, let's put that one on a different bullet point. Right? So the next thing you'll do is you will sum up the amounts by category, so that you can see which category uh, your spending is coming from, so that you can track it. You know exactly where things are or where your money goes, right? So once you have the grouping, then you can make your decision. So for this example, let's just say you found out that you are eating out a lot, like you're spending too much eating out. Um, so now it's time for you to make a decision. So you made a decision that reduce um, eating out expenses, right? So this is the decision that you made based on the data that you have, right? So let's go back to the definition of analytics: using data to answer questions and make better decisions. And that's exactly what you just did on a personal level. You had a question, you collect the data, you transform the data, and then you categorize, you do your analysis, and then you use that analysis to finally make that decision to reduce your eating out expenses. And now let's see how that looks like in a business. So something like where or why revenue is trending down. And as you can already see, or you can already predict, in a business example, you would do exactly the same steps as what we did on a personal level. So um, revenue trending down. So you would collect probably financial statements um, and accounting data. What else? Uh, product analytics data too. Product data. Uh, let's say product performance data. Okay, so you can see how well your product is performing in the last few months, and probably from there you can see that it's only the reduction in revenue is only coming from a single product or product group, right? Maybe you don't know. So but you start with collecting the data. So now you'll put everything into a single place so that you can it's easier for the analytics team to make an analysis. So that's where a data warehouse comes in, which is just a database. Um, in one of the sessions, we will cover this why it's called a data warehouse and not just a regular database. It's more about optimization, but we'll cover that one in another session. So, okay. Now you put everything into ingest data into the data warehouse, and then you make transformations. So by transformation, this could uh, include tasks like cleaning, um, normalizing data, but that's another term that I don't want to discuss yet. So let's just say breaking down wide tables into smaller ones. So if you have a very wide table, like by wide I mean a lot of columns, it will be easier to analyze if you transform it into smaller tables, right? So that's that could also be a possible transformation that you would need to do so that you can do your analysis. And then what happens next is you do analysis, right? This is where your analytics team or data analyst comes in. Now that they have transformed data, they can do whatever they want so that they can answer the question why the revenue is trending down. So let's assume that um, the reason is that uh, the the revenue is trending down because let's just say the data analyst found out that um, the product, whatever the product um, is is not performing well. So, for instance, if this is an e-commerce company, and then the analyst found out that the revenue is trending down because there's a particular product group that is not performing well. Product uh, product group is not performing well, and maybe the reason why is, let's just say it's due to um, seasonality. That means there's just no demand uh, during this period. Yeah, so let's make this simple and let's just say that that's the result of the analysis. The reason why that product group is not performing well is because it's a bad season, right? Now, um, let's say the decision that you guys made is to uh, create a product group that create a new product group with opposite seasonality. So if the company wants to balance out or to stabilize their revenue, if they have a certain product group that is trending down around around these months, then you may want another product group that peaks during this month, whatever that is. All right. I'm sure I can think of a better example, but I think this is already a good start, right? So now let's compare that to the personal example. And as you can see, both example took the same steps, which we can uh, put a label on. So they started by collecting data, and then ingesting, and loading. So by collecting data, that's the step where you have to figure out what data you would probably need so that you can do the analysis. And once you know what data to use, then you can start the next step is to ingest those data into a single place, load it into uh, a database. In a personal example, that could be as simple as a spreadsheet. And then you do transformations, and then you do analysis, and then finally you make a decision, right? So these are the steps, the uh, like the major steps for answering business questions or any questions of that's relevant to the person or to the business. But ultimately, the goal is to make better decision, and that's where analytics come in. Now, now let's move on to who uses analytics, and I already have a list here. Um, so the very first thing that comes in mind of who uses analytics, obviously the people, like as our example earlier, people can do analytics on their own. They can track, for instance, their expenses, like what we just discussed. They can also track their health data through their phone, right? They can also track um, many other data, like their browsing data, their messaging data. There's a lot of personal data that a certain person can analyze on their own. And that allows a certain person to make better decisions. But if we are talking about industries and groups of companies that uses analytics, then the answer is that almost any industry, almost any business that's doing well, even those that are not doing well, for sure are using analytics one way or another. So just a few examples that I have here. Startups, of course. So the goal of startups is they want massive growth and fast growth, right? And so they want, because they're using investors' money. They want to get their return the shortest amount of time. So the first few periods for startups is uh, or building stuff, building products, right? So obviously it's going. There's no revenue first to begin with, but for them to go from negative revenue to break even and hopefully to profitability, they have to make the right decisions, and for that reason they need analytics, right? They need data to help them make decisions. And obviously the tech industry, this is a very healthy example of a group of company that uses analytics for obvious reasons, right? Finance is also a no-brainer because finance is full of numbers. They have all the data, and I would say that most of the people that's working in this industry are quote unquote analysts already because of how often they deal with numbers. Sports and esports, uh, sports like NBA, like FIFA, uh, and football leagues all over the world have very rich data. So they track a lot of statistics, a lot of numbers every second, every minute of play for their analysts to use. Uh, so yeah, it's still a very a good example of an industry that uses analytics, and that goes the same for the esports industry, and many more. Now, the next slide that I have here is the types of analytics. You can see four. Uh, and as we move from left to right, it increases in complexity. And as we move from here upwards, it increases value. So these are types of analytics, but you can also view this as stages of analytics. You can use this one to measure how mature the analytics team is in a certain company. Descriptive analytics is the level of analytics where the questions that are answered by this type of analytics are the what question, like what happened, right? What was our sales in the last 3 months, last 6 months? What's the performance of our products the last 2 years, right? Descriptive analytics answers the what questions. They describe what already happened. It's in the past. Um, the next level to that is diagnostic. So after knowing what the data was, what happened in the past, diagnostic is to uh, go deeper into the data so that you can answer the question why. Why did that happen? Um, and you can only answer that one once you describe what already happened. So once you have the data in place, the diagnostic part is the part where analysts answers the why question they want to diagnose using the data, uh, so that they can give insights to the business. And mm, in many use cases, the diagnostic part, the diagnostic stage, can already answer a lot of business questions. Okay. Uh, and I just want to add that descriptive analytics is also very helpful. This is where monitoring comes in. If you have like a monitoring dashboard or a report, that also falls into the descriptive analytics. But obviously a monitoring dashboard, as the name suggests, is simply a dashboard, a group of charts that's there for the business to monitor. So it just describes what's happening and what's happened in the last few uh, time periods. The next stage to that is predictive analytics. So this is where machine learning comes in many advanced forms of machine learning as well. So predictive analytics is to use your data to to make predictions, to make forecasts of the future. So as you can see, this is increasing in value, but at the same time increases in complexity. At this stage, you would need data scientists, uh, maybe analysts too, data analysts with the capability or have the skills to do machine learning and forecasting. And then the last one, the last stage of analytics is the prescriptive analytics. So this is about recommendations, suggestions. So now that you have, you know what happened in the past, why that happened, and what's probably gonna happen. Now you can now that you have all those views, it's time for you to summarize everything so that you can make a recommendation or a suggestion. So if you are an analyst and you are investigating something, you are expected uh, to to make recommendations to the business, much more like a consultant. Okay, so that's prescriptive analytics. All right, so this is the last one for this session. So let's talk about what's the future of analytics from all these questions that I have here on my slide. So let's start with the first one. How does it look like in the near future? This is quite related to the last question. Will AI obliterate analytics? Um, so let me answer. Actually, let me answer those three in one go. It's the job market. Okay, all of this obviously roots from the fact that AI is rapidly, very rapidly developing, and it's disrupting a lot of industries, a lot of teams, a lot of uh, jobs, right? So how does it look like in the near future? The way I see it, I've been here for uh, let's just I'm just gonna use the total number of experience that I have, 9 years working with data. And if we talk strictly about data analysts, uh, data analysts are expected to, as the name of the job suggests, to make analysis. But what happened before AI? What's happening is that most of the time of a data analyst is not really spent on analysis. Is it's is spent on data cleaning, transformation, writing code like SQL. Uh, yeah, those three uh, tasks alone for STEM analysts, they are already using like 80% of their time doing that, and the rest for analysis. So we are actually not doing what's expected of an analyst, which is to make analysis and make recommendations, right? Because we're doing something else. We're coding, we are um, cleaning data and all that, right? But now with AI, and this is what I experienced firsthand, because AI during this period, right, a specific period, AI can write code, and it's very good at writing code. Um, and it's also very good at uh, searching code bases faster than a human. Obviously, it can crawl all the directories of a code base and give you answers instantly. So what I'm trying to say is that AI is already doing the coding for me and for many analysts and scientists as well. It's doing the coding, and it's not a bad thing. It it is actually making our my job or our job a lot faster. So now that AI it has the capability, and it took away from me a huge chunk of my time coding. So from 80% of my time spent on coding and cleaning and transformation, AI is already handling that part. And what I've seen so far with how I was using AI is that my allocation for doing actual analysis expanded. So from roughly around 20%, maybe I don't have an actual number, but I think it just flipped, right? 80% of my time is now spent on analyzing data. I can complete more tasks with AI. I can generate a lot of insights with AI as compared to without AI. So, what does that mean in the near future? I think we will see an influx of of data professional or data analyst, where the demand will be going to those people who actually have experience analyzing and generating insights, as opposed to analysts who have like heavy experience coding. Because if your experience is just coding, then obviously you can be replaced with AI, right? So you need to develop that skill. You need to sharpen that skill, that analysis skill, because that's something that is very hard to completely replace with AI. So to summarize that part, the job market will be healthy. I would say it's still very healthy, but the expectation for a data analyst will be completely different in 3 to 5 years from now, and that shift is because of AI. Um, and another thing that I want to mention in the job market is that just like many other tech roles that are disrupted by AI at the moment, we will see a decline in junior and entry level roles, and a healthy increase for senior and experienced data professional. And the reason is that AI is considered to be uh, like a junior engineer or a junior analyst. That that's why the entry level roles are also declining, because you have another junior in AI. So yeah, it's going to be challenging for newcomers, but that just means that you will also have to use a different strategy for entering the market. So if you only have like the regular Excel, SQL, and Power BI combo, then you obviously need to expand that, right? Because that's what everyone else have. So you need to find a way to differentiate yourself in this job market if you are just entering this industry. Will AI obliterate analytics? No. But I'll tell you what, the what we are seeing now, ever since Anthropic published how they are self-serving BI using Claude, many other tech companies are doing the same, which is uh, adding that capability in their companies so that they can communicate with their data that's living in a data warehouse or a database somewhere. They can communicate with that data using natural language. So think about it like people just chatting with their data. So if they need certain data, certain analysis, they would just converse with the data warehouse using an AI, right? And for many people, many would assume that that's the death, that's the end of analytics, because I mean the if this works, right, then the company can just ask question, they can get recommendation and business answer just using the chat capability. But what people don't see is that you can't just plug and play an AI into a data warehouse, because somebody has to maintain the context. AI is not going to give you really good answers if your data and your data warehouse lacks the appropriate context for it to produce really good answers. An example of that would be, and this is very common for many companies, right? One metric, let's say revenue, can mean many different things, right? It's ambiguous. So revenue can mean one thing for finance and accounting, but could be different from the perspective or probably product or marketing, right? Or even with data team, probably the data team have a different uh, definition of what revenue is. So there's a lot of those instances in the real world, and AI wouldn't know which of those definition it should use. So there must be governance in terms of metric definitions, in terms of managing the context, the semantic layer, as what they call, to group together all these concepts, and that will be the analytics team. Nobody would is much better fit to do that than the analytics team. Um, so without that semantic layer, it's very hard to trust what the AI is giving you, even if it has direct connection to your data warehouse. And that's also part of uh, the article that Anthropic published, which is they highlighted the importance of having a well-maintained semantic layer. So that also is an answer to how does it look like in the near future, because as I mentioned just a while ago, the roles and responsibility of an analytics team, or maybe a data analyst, would be very different in the future, and maybe the semantic layer is that major difference. So maybe companies and businesses will expect data analysts to know how to manage and handle semantic layers. So yeah, I think I was able to cover a lot of ground in this session. So I'm closing the first session here. Um, the next session will be covering the more on the technical side, like what are the tools that are being used, what are the tech stack, and why they are using that particular stack. So stay tuned. That will be coming next.